Yep, good morning, everyone. Thank you very much for coming to the session. My name is Matt Johnson, and this is kind of a personal journey towards hybrid cloud. So I work for a part of Cisco called DevNet. DevNet is Cisco's developer, basically the one-stop shop for developers. Should there be speakers or any speakers, or am I just shouting? Oh, okay. I will just keep shouting then. That's absolutely fine. Can everyone hear me at the back okay? All good? Yep, perfect. So, as I'm sure a lot of you are aware, Cisco sells a lot of hardware, but we also have software solutions. A lot of our hardware and software have APIs, developer attachment points for developing on or developing with our products. I don't know if you've ever been to cisco.com as a website, but you will find hundreds and hundreds of PDF documents which teach you in excruciating detail how to rack equipment and plug cables in. And it's not the most developer-friendly site. DevNet aims to solve that. So developer.cisco.com, you will find getting started guides, you will find Postman collections, you will find free sandbox access to kind of a lot of the software and hardware solutions we have. So if you're looking to develop on top of some on-prem or an existing customer solution, developer.cisco.com aims to solve that problem and aims to give developers the resources they need without having to kind of hunt through cisco.com as the main site. So my focus is on kind of cloud and containers and all things microservices and platform as a service and Docker and all that good stuff. And I've spent probably 10 years originally as an operations, before we had the whole DevOps movement, just hardcore operations, back rooms, servers, data centers. I've spent about 10 years working through automation, kind of automating production life cycles for code that needed to go into production. Okay, working out how to automate that to better serve developers, how to let developers serve themselves. Through kind of pre-Docker, pre-containers, platform as a service, Cloud Foundry, Heroku, all that good stuff. And we always keep coming back to some of the same issues. And especially when we look at consuming multiple clouds and hybrid cloud nowadays, there are a few common issues we've always hit in the past, which I think actually now we are in an opportune moment to solve. So before we go forward and look at that, I want to go through a brief history lesson. I want to kind of talk you and share with you through some of the pain that I have had getting getting applications into production, right? I'm going to go all the way back to when we had one server. Or if you were a bank or a very rich company, maybe you had two. Maybe you had a primary and a failover. But these servers were really expensive. And you probably gave it a name and you cared very much about this server. This was the only one you had. So the business needed to write some applications and needed to deploy some applications to support the business. So you would get your application, whether it came as an RPM or an apt package, maybe it was a Java executable, maybe it was a tarball of files and libraries and dependencies. And you just took those and you had to place them on the system, okay? And you placed all the dependencies and the libraries and the binaries on that system, and you ran that application, and there we go. The business was happy. You had the application running. And because servers are expensive, and we only had one or two of them, the business then went, well, actually, we need to run the second application. Okay, fine. I will go and install that as well, and it'll run on the same system, and everyone's happy. And then we install the third application. And the third application uses a different version of the same library that application 2 depends on. And suddenly we break application 2. Well, that's not very good, but we only have one server, so what do? So obviously it wasn't good trying to share files and libraries and things between applications. So along came virtual machines. Great. Now, even though I only have one server, it can be separated out into lots of pieces, and application 1 is happy. It can't see any of application 2's files or libraries, and application 2 is happy, and application 3 is happy. All of our applications are running. Great. Happy ops guy, can go on with my day. But instead of just SSHing into Bob every day, Bob was my server, I know what Bob does, I know how he works, I suddenly have 10, 15, 20 servers I need to SSH into. Jane, David, I don't know what your naming schemes were for servers back in the day, but mine were very boring. Suddenly I've got all these different servers, and that means I have more operating systems to patch and secure. I've got more logs to look through. I've got, for every application, I'm suddenly doubling or tripling my workload because I have a whole new operating system and logging and security to think about. So along came configuration management. Great. I'm no longer going to SSH into my servers manually to install applications. Sure, the applications are safe from each other, but when I was managing all those servers by hand, suddenly I'm making mistakes, I'm making typos. The reliability problem was now on me because I'm managing so many servers. So configuration management came along, and I could go, okay, fine. I'll make the changes I want to make in configuration management. I'll start up a fresh test VM. I'll check that the configuration management changes make the application work or update the application or whatever I'm trying to do. And then once I know that's going to work, I'll run that same configuration management against my production VM. Perfect. And configuration management is great. Puppet, Share, Ansible, pick your favorite. I don't want to leave anyone out. It's great until it isn't great. And when it isn't great is at about 3 a.m. in the morning when ops guy Dave gets a call, and it's his boss's boss's boss. Going, everything's broken, it's broken, we're losing £1 billion a minute. You need to fix it right now. And what Dave isn't going to do is go, sure, that's fine. Let me spin up a test VM, and let me make some changes in configuration management, and let me test those against the test VM, and then I'll give you a call back in about an hour when that's done, and then we can fix... No. Dave's going to jump straight onto the production system. He's going to fix the problem. He's going to save the day. But then Dave comes into work at 8 a.m. the next morning, a bit tired, and gets on with his day job, checks his emails, carries on with everything he was meant to be doing. And then maybe a few months later, Dave leaves the company before the next big deployment and goes somewhere else. And Dave never put that change he made at 3 a.m. in the morning when he was being screamed at down the phone into configuration management. Configuration management's like that Visio diagram of your network. It's what you think your network looks like, but it never really is, because change is always, for various reasons, slipped through the net. Which means the next time we do a configuration deployment through config management, we again break production. So we've moved from apps killing each other to human error to now not keeping configuration up to date, which is causing downtime. So some very clever companies had a great idea. They thought, well, hang on a minute. We're already writing configuration management, proving that it works into a test VM. Why do we then have to go and update a production VM? If it's working perfectly in that test VM, why don't we just snapshot that using the existing VM tools we already have? We know it works. We also know that because it's a brand new VM that we've just run configuration management on, there's no history. There's no weird changes at 3 a.m. that we don't know about. So we started getting into a mutable infrastructure. So suddenly, I don't just run it to test and then update my production VM. I take a snapshot of my test VM, kill the old VM, replace it, and that new image becomes production. So great, we're getting more and more closely to stability. It's harder and harder for things to go wrong. We're not SSHing into systems to fix them at 3 a.m. Even if we did, the next time we do a deployment is a completely fresh VM with a completely fresh install. It's not going to be affected by that. We know that we've already tested that new VM in testing. So this should be solid as a rock. And it is. This is a really good way of doing things. So much so that if we look at containers, we're basically doing exactly the same thing. Sure, the tooling has changed. The tooling for actually creating that sealed image in a container is a hell of a lot easier than creating a new VM and installing an operating system and getting the security patches, and then running configuration management. We just do Dockerfile, Docker build, boop, good. But it's the same concept. We're putting everything we need into a new, fresh image. And then when we deploy that image, do we update our old Docker container? No, we don't. We kill the old image, and we replace it with the new one we've just built. So containers are doing what we were doing with, what some people were doing with VM images years ago, right? So sure, they're lighter weight. You don't have to carry 80 gig operating system images around between your data centers to do deployments. And the developer tooling for building those images is a lot easier. Yep. But why is it taken off now? Why am I here talking about containers enabling hybrid and multi-cloud rather than this stuff that we clearly already had years ago? And the problem is that VMs weren't all created equal. This safe way of snapshotting and deploying is great. But what am I creating if I do this in a VM instead of a container? Am I creating a VMware VM? Am I creating a VirtualBox VM? Am I creating an OpenStack VM? Am I creating a VM that's destined for Amazon EC2 or Google Compute? Sure, they're different file formats, and we can change between them. But what we cannot change in the VM world is when we actually come to look at deploying those VMs. My deployment automation for deploying to OpenStack is completely different than my deployment automation for deploying to Amazon EC2 or Azure or Google. And I feel really bad for leaving anyone out. So pick your favorite cloud provider, Packet, DigitalOcean, whatever. The APIs for each of those environments are completely different. So sure, we've got this image. It's kind of like a container. But for every environment I want to support, for every, let's actually support more than one cloud provider, or let's do on-prem and cloud. For every environment I need to support, my development overhead for deployment tooling is linearly increasing. It's O of N. We have to add a new set of tooling to our deployment pipeline to deal with the different APIs and the different ways of doing deployments in each of those environments. And sure, there are tools to try and make that easier. Terraform, the whole point is, doesn't matter what cloud or it doesn't matter where I'm deploying VMs, right? I can write a Terraform manifest to know how to go and talk to AWS or talk to OpenStack or talk to vCenter and build me a VM. But if we actually look at the definition of Terraform spinning up a simple VM in Google Cloud, and we look at Terraform spinning up a simple VM in AWS, they're still completely different. Yes, it's the same tool, but you're managing a configuration file then for each individual cloud provider or each individual on-prem provider. So doing multi-cloud doesn't feel like you're doing a single deployment. It just feels like you're managing lots of environments, and that comes with complexity and added work for your deployment tooling. And the more you repeat yourself for different environments, the more chances are of mistakes. And containers could have missed this boat as well. If we think about when we started with containers, sure, I have one container image. Docker's pretty much the universal image, right? There's no VMware VM or OpenStack VM or anything like that. There's a single image format. But what am I deploying that down to? Am I deploying that down to the Mesos Marathon APIs, the Mesosphere DCOS APIs, the Kubernetes APIs, the Docker Enterprise Edition APIs? We could have been in exactly the same position as we were with VMs. But we're not. Because Kubernetes, in this case, has kind of won, hasn't it? And certainly I'm drinking a bit of the hype and a bit of the Kool-Aid there. But the reason I'm saying it's won is everywhere you want Kubernetes, someone is willing to give it you. Even cloud providers that have made money on only having proprietary APIs that lock you into their environments. They don't want to miss out on the number of people that want Kubernetes. They don't want to miss out on people paying them for that compute or that service. So you go to Google, you say, give me Kubernetes, you get a Kubernetes API. Amazon, Azure, on-prem, you can get a Kubernetes API wherever you want. Which means for the first time, we're in a very different world than previously. And certainly as far as I can remember. Correct me afterwards if you disagree, but imagine a world where the OpenStack API supported the VMware vSphere API and vice versa. And they also both supported the EC2 API and the Azure Compute Stack API. Imagine a world where automating deployments for any environment was one and the same thing. And that's quite powerful. Because now, with the ability to get Kubernetes everywhere, we are, for the first time, in a position where we can define our application once. We can define our application deployment tooling once, because we have a consistent abstraction layer. Whether we are on-prem, whether we are in multiple cloud providers, Kubernetes gets us to that single definition, where we don't have to worry about, oh, well, this is a Terraform manifest for EC2, and this is a Terraform manifest for Azure. We're finally in that position. And this is really testing me because I can't see any of the slides coming up next. So, what's the best way to enable hybrid or multi-cloud in 2018? Get to the Kubernetes API as soon as possible, if your workloads support it. Because that means you're saving time learning different ecosystems for every environment, learning how you do certain things in EC2, how you do certain things on-prem. Get to the Kubernetes API because it gives you the consistency to focus on your application deployment, not on your underlying 1,000 different provider environments. And sure, just because you say I want Kubernetes doesn't mean you wake up tomorrow morning and every provider you can possibly think of has magically known that you want Kubernetes and has gone, oh, I'll provision James a Kubernetes cluster in Amazon and in Google. You're still going to have to do some work to automate the spinning up and provisioning of Kubernetes clusters everywhere you want them. But more and more, that's actually provided as a service because people want your business for this. So suddenly your tooling per environment goes from a load of Terraform and a load of mess for VMs to just enough per environment config to get you that managed Kubernetes cluster. Okay? And it's not something you need to revisit per app deployment or per every time you release a new version of a VM. The actual per environment differences just become, what do I need to do to get that provider to give me Kubernetes as a service? And I say as a service, you do really want Kubernetes as a service. Your business is probably in the business of making money through your applications, adding value to your customers or your partners. Your business, there could be a couple of people here that I'm wrong on this, and your business is, look at my shiny custom Kubernetes cluster. But most of you, your business probably isn't, look at my shiny Kubernetes cluster. You don't care. You just want to know two things. Number one, have you built me a Kubernetes cluster? Yes. And number two, is it working? And will you fix it for me if it goes wrong? If the answer to both of those is yes, just consume Kubernetes. Get on with adding business value rather than look at my shiny cluster. So I've just been preaching, get to a layer that's the same everywhere. Let someone else deal with the underlying stuff, get to that Kubernetes layer, then you can define your application once, and everyone's happy. And now I'm going to kind of ruin that because I'm preaching all these wonderful, simple things. And it's never quite that simple if you need on-prem, whether it's GDPR or low latency or data sovereignty or whatever the reason is, edge compute for certain streams of data. When you're on-prem, that just give me Kubernetes doesn't really work, does it? Because when you ask Google or Amazon or Azure, hey, give me a Kubernetes cluster, you don't care how Google is configuring the etcd cluster, that the Kubernetes master relies on. As a developer, you probably shouldn't even care that there is an etcd cluster that the Kubernetes master relies on. You don't care what configuration management tool, or not, they're using to install the kubelet on your worker VMs. No, you just want to go, hey, Google, give me a 4-node GKE cluster. Yep, there you go. Here's your API URL, here's your credentials. You don't care about any of that. Historically, that's very hard to say about on-premise. On-premise, there is no one in your corporate environment that you can go, hey, give me a 4-node Kubernetes cluster. They'll go, okay, well, have you spoken to the VMware team about getting some VMs? And then do you need IP addresses? You need to speak to the network. And will these need to access anything like the internet? You'll need to speak to the security team and this and this and this and this and this. You know, there's no provisioning API for Kubernetes on-prem, which kind of is where this whole idea breaks down. And Cisco saw that as a bit of a gap. So obviously, this is the product warning. This is where I now talk about product. Private cloud, to be useful in this wonderful new world I'm preaching, needs to feel like public cloud. It needs to be instant. It needs to be API accessible. It needs to be of a known quantity. Hey, Google, give me a 4-node Kubernetes cluster. OK. Hey, on-prem, give me a 4-node Kubernetes cluster. OK. If it's any more than that exchange, then developers are probably going to work around or end up building kind of snowflake environments on-prem, because actually trying to build something like they have in the public cloud is too hard, too many teams. It's just not managed itself. So we've released this product called Cisco Container Platform. And it's a curated stack of hardware and software, like the Apple model. We know how it's wired, from power and networking at the bottom and cooling to software at the top. And what CCP basically gives us is a Kubernetes as a service provisioning API for on-prem. It's a known quantity. You can say, hey, CCP, give me 4 Kubernetes clusters, each with 5 worker nodes. Great, done. OK, we'll scale that one to 8 worker nodes, or upgrade that one to the new version of Kubernetes. It gives you full lifecycle management like you would expect from public cloud on-prem in a known quantity. And that is literally wheelable in, turnkey. We now have what we need on-premise to tie into this vision of a single interface everywhere. So just a note on CCP there. And the whole point is it gets you to Kubernetes, and that's really what we care about. And obviously, it has APIs like you would expect. Like I can ask GKE and Amazon and Azure. You have to have those APIs to tie into your either existing provisioning systems or to support developer self-service. So full Kubernetes as a service on-prem. So that's the end of my on-premise sidebar. So is my talk just about, get to Kubernetes, that's it, great. You've solved hybrid, you've solved multi-cloud. Obviously not. But it does give us the right mindset. This idea of find something which gives you an identical API for every environment you want to be in, so you're not constantly inventing new custom if-then-else statements for every environment you want to deploy in. It gives us the right mindset for thinking about the other challenges that we will face with multi-cloud and hybrid. And to me, by the way, they're the same. I don't care whether you're using a private cloud and a public cloud, or you're using 3 public clouds. This idea of having a consistent experience across all of them is really what I'm talking about, regardless of which one you're trying to achieve. So carrying on this idea of the Kubernetes single deployment, like in my personal opinion, hybrid cloud, multi-cloud, if you're doing it right, it should feel like one environment. It shouldn't feel like you're having to manage X, Y, and Z environments. It shouldn't feel like there's extra effort to support a new environment in that puzzle. You should be doing everything you can to try and make that feel like you are managing one cloud across providers. And it shouldn't linearly increase with complexity. It goes back to that deployment tooling thing we were talking about earlier. So Kubernetes gets us quite far with abstracts for these things. It gives us deployments, which we've already talked about. One manifest that works everywhere. It gives us persistence. I can actually say to Kubernetes, hey, I don't care where this environment is, but I know that this app will need like 20 gig of persistent storage, and if the app crashes, it needs that storage back so it can carry on its queue or its state or whatever, okay? You know, more complex applications do need temporary persistent storage. And Kubernetes can give us that. We don't care about whether it's creating a EBS volume in Amazon or an iSCSI dynamically provisioned LUN on-prem. We just don't care. Kubernetes will give us that abstraction. It gives us services. Hey, I don't know what the networking is in this environment, but I do know I need an IP address that's publicly reachable at the front of this service, and I want you to automatically load balance through however many instances of this application I spin up. It will give us that. But what else can we do? What else moves us closer to this idea of it should feel like one environment? Well, the first thing is just because you can deploy, hey, Kubernetes, go and deploy my application over here. Kubernetes isn't magically going to know you have 5, 10 different Kubernetes clusters. There was historically this distributed Kubernetes effort which basically tried to overlay like multiple environments onto the Kubernetes API. So in your deployment manifest, you could not only say, hey, this is my application deployment, but also deploy it to site A and site B and site D. That didn't really work because the Kubernetes kind of deployment language doesn't really fit to a multiple environment model. If I then say in that same deployment manifest, I need 20 gig of persistent disk, how is Kubernetes going to manage to copy 20 gigs of data over there when I deploy it over there? You know, it doesn't quite work. You define applications in Kubernetes in a way that doesn't really lend itself to explaining where you want that deployed and which apps you want where. So the way to put your deployment logic for multiple environments to make it feel like you're managing one environment is in your CI/CD system. I was talking to Kelsey Hightower from Google Cloud about this because he knew about the previous efforts for federated Kubernetes. And I was asking him why it went away and how people were doing it these days. And the answer is in CI/CD. Because the only team that knows how they want to consume multi-cloud or hybrid cloud is that individual team. There's not a cookie-cutter solution for it. I don't know whether you're looking to hybrid cloud for cost savings or latency or resiliency or customer data protection. So the only person that knows which bits of your applications and services need to go where is you, which means that your CI/CD system, your automatic deployment pipeline, is the right place to put that business logic. And by doing this and having one app deployment manifest for all your environments, we've already saved you a load of time tooling different APIs for your deployment pipeline. So reinvest some of that time in putting your multi-cloud, hybrid cloud logic into your CI system. The next thing that always breaks down when we talk about hybrid cloud, multi-cloud, more than one environment, sometimes more than one data center of the same provider, regardless of whether you're using hybrid or multi or not, is data services. There's a couple of ways you can do data services. You can either go, oh, it's fine. All our data services are third-party SaaS and someone else will deal with them. Or you end up having to run your data services somewhere. Now, more and more people are running data services as Kubernetes deployments, just like applications. That's great. But if you're not in that situation, what are you going to do? Because we've just spent a load of time making sure you don't have to retool your deployment system for each environment. And you've got this lovely shiny Kubernetes cluster everywhere. But if your applications then still rely on a data service in that environment, and you're used to deploying your data services by spinning up VMs, suddenly it's not your applications in VM images, it's your data services in VM images, and then you're still back to, is it an OpenStack API, is it vSphere, is it AWS, is it Azure? You've got this lovely Kubernetes cluster, and then you're still doing all the deployment work of multiple environments because you still need to deploy VMs for your data services. What we want is something that abstracts for data services the same way Kubernetes abstracts for that single definition of my application. We want something where I can go, hey, environment. Here's my application. It requires 20 gig of relational database. I don't care where you find that. I don't care what environment I'm in. If this ends up getting deployed on AWS, give me... I've actually forgotten the name of AWS's relational database product. Never mind. If I'm deploying this on Google Cloud, give me a 20 gig Cloud Spanner instance and automatically provision that and pass the credentials and the connectivity information into my app as environment variables so that my app can consume that. If it's on-prem, spin me up a Kubernetes-based stateful set solution which gives me a 20 gig MySQL instance and provide the details to that so I can get to it. And there is a project called Open Service Broker, as you might have guessed. And this basically does that. This gives us the same abstraction for data services that Kubernetes gives us for app deployments. So I define what I need, not the specific product or the specific marketing name for that provider's version of that thing. I just define what I actually need. And then the Open Service Broker will translate that down into creating something that is fit for that environment. And actually, this is quite cool because across multiple environments, you can even say, well, actually, both of those applications need to bind to the same instance of a specific database. So let's take a message queue. You can actually use Open Service Broker to make sure that no matter where your application instances are being deployed, they can all tie back and subscribe to the same pub sub and things like that, which is quite beneficial. But again, defining this in a defined once kind of way. You're not going, oh, and I need to do this from here and that from there and open these ports so that this can get to that. Open Service Broker takes that complexity away from you. And that'd be really cool in itself. But it's even cooler in the fact that like Kubernetes is being supported by all the cloud providers, Open Service Broker is starting to be supported by all the cloud providers. So Amazon and Google Cloud both provide Open Service Broker API endpoints that understand a lot of their data services. So you can already start using this cross-cloud and hybrid to public without having to go and write a lot of that back-end logic in Open Service Broker yourself. So what else can we do? And I'm very aware I'm short of time. What else can we do to make it feel like one environment? Well, security is very close to my heart. And I don't, it's not going to feel like one environment if I have to go to my on-prem security dashboard and look for issues and then correlate that manually with whatever kind of security visibility AWS gives me for their Kubernetes cluster or their, ingress IP addresses or whatever the dashboard is for Google Cloud, right? If I'm checking 3 different places for 3 different environments for security issues, I'm going to miss something, I'm going to not bother, or I'm just going to hate my life because that just sounds like a really depressing job. So again, let's look at what we can do here. I'm just going to skip this. Cisco happens to be a world-leading provider of as-a-service security solutions, which you can basically point data at, or you can install agents in your environments to look for anomalies in east to west traffic between your apps, in DNS traffic that might suggest an indication of compromise. Use those. Like some of them, like Umbrella, are practically free. Use those to at least give you a single source of are there indications of compromise in my environment. Okay, use the tools that are, again, and because it's SaaS, you don't have to worry about deploying it in each environment. Just get the data to somewhere central to make it feel like one environment so that you can study it all in one place and get some sensible mapping between different things going on in different environments. I know we're running out of time, but I actually think that's really cool, by the way, because a lot of our SaaS security products have APIs for events and real-time hooks into them. And actually, containers and Kubernetes gives us a really interesting way of thinking about dealing with security issues. If we can detect an indication of compromise fast enough, and we can know which individual pod that indication of compromise came from, we can just shoot that pod in the head, and Kubernetes will bring up another one. And sure, the attacker may retry, and the load balancer will send them to another pod, and they will run the same zero-day exploit, and then that one gets shot in the head. And if we can detect that indication of compromise quick enough before they start trying to pull down DNS queries to install extra tools and start looking at the rest of the network and enumerating their position and trying to grow their position inside your network. It turns something like a 6-month, target or financial institution where they end up exfiltrating months of data into okay, we know this application's being hit, we know it's vulnerable, we can now take the business decision to either leave it on because we're not that bothered or turn it off. That indication of compromise is actually more important, than knowing 6 months down the line you've been hacked. And then finally, and I'm going to close on this, something else I think is going to become more and more important for making our environments feel like one is the service mesh. And again, I am massively drinking the Kool-Aid here. But the service mesh, I think, is really exciting. It basically gives us an abstraction layer for how services should talk to each other. Again, regardless of environment. App A needs to talk to App B. It shouldn't be allowed to talk to App C. Users have to have a valid SSL certificate before they can come to here, but they can get to here anonymously. It lets us define our security policy in one place for our applications. So we've got Kubernetes letting us define our apps. We've got Open Service Broker letting us define our data. We've got Istio letting us define, and Service Mesh is letting us define our security posture. And we define all of those once, regardless of where we're deploying our applications, regardless of which environments we're deploying, multiple at the same time. Although I do think work needs to happen on service brokers. At the moment, we're treating them like an extra bit of Kubernetes. I have a Kubernetes cluster, and then I have a service mesh. And then over here, I have a separate Kubernetes cluster, and I have a separate service mesh. And if you try and link them together, and Istio's just started supporting this, it's nasty. You need to do things like manually create VPNs and make sure there's no overlapping IP ranges between your clusters. Again, that just doesn't feel like one environment. That feels like a bit of a hack. So I see Service Mesh growing into almost like a policy-based CDN, where it can work out which routes between Service Mesh nodes are in the same environment or which need to be tunneled over TLS, not manually created VPNs with IPsec and things, so that we can truly do that, define our policy once, regardless of where our deployments end up. And we know that the user is going to get a consistent experience. We know that our security posture across our entire estate is sane, because people haven't misconfigured something in Istio A that's letting people actually access things they shouldn't be able to get to. Again, configure things once, and you're going to make less mistakes replicating your environment. And that is my talk. I have no time for questions, so please do come find me afterwards if you want to chat or swap details or whatever, or just give me some negative feedback. That's fine. I'll be sticking around there. And thank you all for listening. Really appreciate it.